Good morning, good afternoon, students. In the today's class, we will discuss about the general principles and process of isolation of elements. Okay, that is very important chapter. So it carries more than 100 plus 150 plus questions in the previous years overall if we gather names. Okay, so this is all the topics in this chapter is very important. Basically, occurrence of metal, concentration of ores, extraction of crude metal, thermodynamics principles of metallurgy, electrochemical principles, oxidation, reduction, refining, and uses. So in that, students, the very important thing is important ores of different metals. So I have some list here. So I'll go through that, students. You note down that, you keep on practicing the ores, different ores of the different metals that will help you in the NEET examination. So I'll start with lithium, sodium, first group, second group, like that. Okay. So in the first group element, second group element, especially S block and P block elements, ores are very important. Okay. So I'll write important ores here. So that is first one, sodium. So important ores of sodium, sorry, not sodium, lithium. Lithium comes first, right? So lithium important ore is triphyllite. Okay, its composition is Li thrice into PO4. Okay, so similarly, spodumene is there, that is LiAlSi2O6, lithium aluminium silicate. Next, sodium. In the sodium, borax is there. You know very well about that borax, the S block element. You already studied about that. This is the formula of borax. And cryolite is there. So this cryolite is used for what? Leaching of aluminum. Extraction of aluminum from electrolysis process. Okay. So another one is mirabilite. Mirabilite means sodium sulfate decahydrated. Another one is common salt. Common salt, you know, that is NaCl. Okay, washing soda is there. Washing soda formula Na2CO3 into 10H2O. Soda ash formula Na2CO3. Okay, baking soda is there. That baking soda means NaHCO3. These are the different compounds of sodium. Ores, especially ores of sodium. And potassium is there. For that potassium, carnallite. Okay. So this carnallite means KCl in GCl2 into 6H2O. This is a double salt. Similarly, polyhalite is there. That is sodium, potassium and magnesium sulfate salt. Okay, so this is potassium and magnesium chloride means carnallite. Potassium and magnesium sulfate means polyhalite. Okay, you have to remember this, students. Nothing easy trick is there. You have to remember this. You have to be thorough with this. Keep on practicing every day. You will get. So another one is, that is KNO3 nitrate, called as Indian salt petrate, and feldspar This feldspar means K2O Al2O3 into 6SiO2. Okay, so this is what ores of potassium. Similarly, ores of magnesium is the dolomite. Dolomite means magnesium and calcium carbonate. Okay. Similarly, cornellite is also there. That is also a ore of what? Magnesium. Correct. So next, talc. Talc is there. That is MgO SiO2 into H2O. Magnesium oxide with silica. Okay. Next, a very important thing, that is Epsom salt. Epsom salt, that is magnesium sulfate. It's a hydrated which you are going to use in the salt analysis. This is Epsom salt. Okay. And another one is the important ore, that is magnesite, that is MgCl3. Okay, students. Next, here calcium is there. It is one of the ore of the calcium. Understood? So the next one important ores is there. That is, as I told you, for aluminium. This is very important thing which you are going to study. So aluminium, the aluminium ore is bauxite. Okay, so bauxite means Al2O3 into 2H2O. Correct? Mica is there. Mica means K2O Al2O3 SiO2 into H2O. Mixture of this one. This is 3 times, this is 6 times. Okay. Next, cryolite is there. Cryolite means Na3Al6. Okay. So this is the ores of aluminium. In this is the chief ore of aluminium, that which we are going to extract aluminium metal from the respective ore. So this is ore of aluminium. Next one is ore of copper. Okay, so first the main ore of copper is malachite. What is it, malachite? Copper carbonate into copper hydroxide. Okay, next, chalcocite is there. That means Cu2S. This is also called as what? Copper glands. Okay, students. Another one is, that is copper pyrite. So copper pyrite means CuFeS2. So this is called as fool's gold. 1 gram gold, that is fool's gold. It look like what? Gold only, but it is actually a copper. So copper pyrite CuFeS2. And also cuprite. Cuprite means Cu2O. This is called as ruby copper. This is called as ruby copper. So another one, these are all given in what? NCERT. Okay. So another one is there, azurite. This azurite means 2 moles of this copper carbonate and copper hydroxide. Understood? So this is the ores of copper. If we take ores of silver, the main important ore is horn silver, that is HeCl. Horn silver, that is HeCl. Next, argentite, called as what? Silver glance. So students, here we wrote copper glance means Cu2S. Here we taken silver glance. That means what? Ag2S. Understood? Next, ruby silver. Ruby silver is also there. That means Ag2S, Sp2S3. This is called ruby silver. So the important ore of mercury, only one ore is there, that is cinnabar, it is HgS. Understood? Only one ore is there, that is cinnabar. The formula is HgS. Next, ore of zinc and ore of iron. Ore of zinc is zincite is there, that is Zadano, correct? Next, zinc blend is there, zinc blended, that is 7S. Next, willemite is there, willemite means zinc silicate. Okay. Next, calamine is there. Calamine means zinc carbonate. Understood? So these three you already studied in what? NCERT, extraction of isolation method. In the theory class I explained this. So this one extra you have to remember. Willemite means zinc silicate. So important ores of iron means, in that iron pyrite is there. Iron pyrite means Fe2. Next, siderite is there. Siderite means FeCO3. Okay. Next, hematite is there. Hematite means Fe2O3. Magnetite is there. Magnetite means Fe3O4. Okay. So another one is there, that is limonite. Okay. Limonite means Fe2O3 into 3H2O. So these are all the important sources of iron. Okay. Similarly, so many ores are there that are very important, students. So this is what I given is important as regarding NEET orientation. Okay. So next, once we know the horse, so then we will shift to what? The steps involved in what? Metallurgy. And write like this, that is steps involved in metallurgy. So what are the steps involved here, students? First, we are going to extract, or we are going to get the different ores of the respective metals through mining. Okay, that is extraction of, and not extraction, actually getting a mineral from the earth crust. So that mineral consists of what? So many impurities. So among those minerals, we will choose one of the any one of the mineral to or as a ore to extract the respective metal. So that ore is mixed with what? Not mixed with, actually it consists of so many impurities. Okay, so first that ore is finely crushed and finely grinded to what? Powdered ore. The raw ore which we are going to extract from the mining, it is crushed into a fine powder. That powdered ore, okay, is subjected to what? Concentration. So the concentration terms includes what? Mechanical separation, levitation, magnetic separation, flotation, electrolytic method of concentration, leaching, electrostatic separation, amalgamation, optical separation, etc. So many separation techniques are there. Once the concentrated ore is takes place, what is the concentration of ore? Removal of unwanted impurities present in the ore particles. Once we remove the unwanted impurities as gangue particles, then we get the concentrated ore. So that concentrated ore is converted into what? Oxide. There may be, the ore may be in the form of carbonate, in the form of oxide, in the form of sulfide. So students, in the elegant diagram, if we convert the any of the ores into oxide, that will be easy to reduce them with the carbon and carbon monoxide. Okay, so that's why all the ores, the concentrated ores is converted to what? Oxide. So conversion of concentrated ores into reducible form, that is oxidation form, will take place by calcination and roasting method. Okay, so oxides are alloys of metals. So oxides are also there, halides are also there. With respect to them, what? They'll reduce us to their different metals like smelting, hydrometallurgy, auto reduction, electrolytic reduction, aluminothermic reduction, reduction by metals, reduction by carbon. Once the oxidation takes place, next one is the reduction process. So those are all the reduction process here. Next, once the oxidation and reduction process done, then we will get the crude metal. Crude metal means this is not 100% pure, but somewhat the concentration of the metal is high. So that is crude metal. So once we got the crude metal, we'll use to get, or we'll use to refine that, then we'll get a pure metal. That is the process involved in extraction of the metal. So step one is what? Ore. First ore, that is extracted from earth crust. Next, this ore is crushed and grinded. Then it become what? Powdered ore. So this powdered ore is subjected to what? Magnetic separation, hydraulic washing, flotation, and leaching, and electrolytic separation, etc. Then if the powdered ore is subjected to this type of separation techniques, then the impurities are removed as gangue particle. Impurities removed as what? Gangue particles. Then we will get concentrated ore. Understood? Then we will get concentrated ore. So if this concentrated ore, then it changes to what? Oxidation and reduction process. Oxidation takes place by two types. One is calcination, another one is roasting. So students, what is oxidation means? Addition of oxygen, you may say, or carbonate ores are there, sulfate ores are, sulfide ores are there, and oxide ores are there. So here what is called calcination means the burning or the supply of, or you may combustion of a ore or a burning of a ore takes place in the absence of the air or the limited supply of the air. Okay, so the calcination means the oxidation process or the burning process, combustion process takes place by what? In presence of air, sorry, in the absence of air or the limited supply of air, then the oxides and carbonates ores are converted to what? Oxide ore. So if oxide ore is there, I'll take example Al2O3 into 6H2 I say means if this type of ore undergoes calcination means what, upon heating this water molecule removed and become oxide ore. Okay, so hydrated ore becomes anhydrous. Understood? So calcination means the heating of a concentrated ore in presence sorry, in limited supply of air or in the absence of air. So carbonate ore is there, that is CaCO3. So upon heating it forms CaO plus CO2. So here carbonate and this hydrated ores, oxide and a carbonate ores are converted into oxide ores here. And next one is roasting. So roasting means the heating of a powdered metal or the concentrated metal in presence of the air. Okay, in presence of that, in the sufficient supply of the air is called as roasting. In this sulfide ores gets oxidized. For example, ZnS is there in presence of O2. If it is roasted means that is 2ZnO plus SO2. 2ZnO plus 2SO2. So sulfide ores upon roasting changes to what? Oxide ores. So in the reduction process we take means either this undergoes oxidation as well as reaction. Once the oxide ores are oxidized, then they undergoes reduction. So what are the reduction methods? Here it is melting. Okay. Next, hydrometallurgy. Next, auto reduction. Next, reduction by suitable methods. And another one is reduction by carbon. For example, ZnO is there. If it is treated with carbon, then it forms zinc plus carbon monoxide. If zinc is there, then it is replaced by copper, then it forms CuO plus Zn. This is the way, either by using metal or by using carbon, we can reduce the respective oxides. So the concentrated ore is subjected to oxidation and reduction. Oxidation takes place by calcination and roasting. Reduction takes place by any one of these methods. So preferably we choose reduction by carbon and reduction by metals. This is the very easy and suitable method to reduce the respective metal. Okay, so this is the way to get the concentrated ore. So students, once this oxidation and reduction undergoes, so then what? It forms a crude metal. Then it forms a crude metal. Okay, so what is this crude metal? I get here. So listen, crude metal is there. So crude metal means it is somewhat impure, not exactly pure, somewhat impure. So this pure metal is subjected to what? Refining. Okay, so what is this refining method? It may be distillation, liquefaction, correct? Boiling, filtration, okay? Zone refining, electrolytic refining, vapor phase, okay? Or chromatography. So by the refining techniques, we will get a pure metal which we can use commercially. So this is the process. So students, first steps involved in metallurgy is the extraction of ore. So extraction of ore is takes place from the earth crust. The ore is finely crushed and grinded and made it into powdered ore. That powdered ore is subjected to remove the impurities in the form of a gas by using some certain techniques. Then the concentrated ore will form. This concentrated ore is subjected to oxidation as well as reduction. Then it gives crude metal. Once the crude metal is formed, that crude metal is subjected to different zones of refining, then it gives pure metal. That pure metal is used to commercial uses or commercial purpose. This is the methods used in the metallurgy. Okay, so then very important thing is the extraction of some important metals. I'll go one by one. That is extraction of aluminium melting. Extraction of aluminium. The main ore for that is ore, that is what? Bauxite. What is the formula of bauxite? Means Al2O3 into 2H2O. So among this, it may taken cryolite. Cryolite means Na3Al6. These two ores we will consider. So ore is taken means then it is what? Concentration of ore takes place. So listen, as I told you, once the ore is done by the leaching process, we will get, this is leaching process, we will get concentrated ore. Okay, so that concentrated ore is subjected to what? That leaching process, how it done? By treating with NaOH solution. So listen, this Al2O3 is there. If it is treated with NaOH solution, it forms sodium aluminate. Okay, so this NaAlO2 is subjected to water molecule, then it forms aluminate ion or aluminum hydroxide with NaOH solution. Okay, so this aluminum hydroxide is heated, then it forms aluminum oxide plus H2O, 3 moles of H2O. Understood, students? So this will give what? The leaching. Here we will get this Al2O3 into H2O is separated as what? The hydrous become anhydrous here. This is plus 3H2O. Understood? So then if we will get this undergoes what? Oxidation as well as reduction. This is already a oxide ore, that is Al2O3 means if it is upon heating means itself it is what? Calcination. Then it form hydrated ore become anhydrated. So then this one is what? Aluminium oxide. So this aluminium oxide is subjected to what? Reduction. Which type of reduction? Electrolytic. Electrolytic reduction. How it takes place? This process is called as Hall Herold's process. Okay, so how it's taken, students? This aluminium oxide is treated with this cryolite. Okay, so then this Al2O3 is dissociated by as well. Al plus 3O2 minus plus. Okay, so this is loss of electron, or this ionization takes place. This Al3 plus accepts 3 electron from here and forms Al. This is the reduction process. Once the aluminium is extracted, then it is subjected to refining. As it is an oxide ore, it is less impure. Understood? This is what aromatic, that is purification by what? Hoops method. Hoops process. So student, first, ore bauxite is concentrated through leaching. This leaching ore is undergoes for electrolytic reduction. As I told you, the concentrated ore is subjected to oxidation as well as reduction. Oxidation means here this is calcination undergoes, and this is reduction. Then we will get a crude metal. That crude metal is subjected to purification by Hoops process. Okay, next, extraction of iron. Extraction of iron. So for iron, we'll choose hematite ore. FeO. This is what? Blast furnace. Important for 3 marks, you know that. Okay. So this hematite ore, as it is an oxide ore, that and this iron is strongly attracted by the magnetic field, means this concentration takes place by what? Electromagnetic separation. You know, as it is iron is most preferably attracted by magnetic field, means it is separated by magnetic separation techniques. Then we will get concentrated FeO. Okay, so FeO is a oxide ore, so it undergoes what? Calcination. So if it undergoes calcination, if any water molecules or any other impurities are there, they are easily removed. Okay, so in that, so listen, assume if Fe2O3 is with H2O molecule, then it is changes to Fe2O3 plus H2O. If sulfur is there, then it forms to sulfur dioxide. If iron carbonate is there, then it is changes to FeO plus CO2. If any impurities are there, that can change to this byproducts upon calcination. Okay, so the next one is, once the calcination we got, that is Fe2O3 ore we got, understood, then this will subjected to what? Smelting, oxidation and reduction. Smelting means here it is blast furnace. Smelting takes place in what? Blast furnace. First what happens? This Fe2O3 mixed up with carbon monoxide gives 2Fe plus 3CO2. This is 3C. Okay. Here the temperature ranges from 400 to 700 degrees Celsius. Understood? This is 3CO. To this, CaCO3 is added, which upon decomposition gives what? CaO plus CO2. The CO plus CO2 is mixed with SiO2 form CaSiO3, that is slag. Okay, so this one is flux. This one is gangue. The impurity is gangue. This one is flux. This one is slag. Okay. Next, this is zone of reduction. This is zone of slag formation. Another one is there is zone of combustion, that is C plus O2 gives rise to 2CO, and 2CO plus O2 gives rise to 2CO2. This is zone of combustion. Okay. So this is all about smelting process, students. Here from the blast furnace, the iron obtained is called as what? Pig iron, consists of 4% carbon. Okay, so it is called as pig iron, consists of what? 4% iron. Then it is again heated and formed to cast iron, consists of 3% carbon. This cast iron is removed and it is made it into, and it is subjected to coal, that is called as wrought iron. Okay, so the iron extracted from this blast furnace is a pig iron, consists of 4% carbon, and again it is purified. Then it is cast iron with 3% carbon, and then completely removal of this carbon takes place. That gives wrought iron, which is used for commercial process. Okay, and this purification of this iron is takes place by reverberatory furnace method lining with hematite ore. So this is all about the extraction of iron. Next, extraction of zinc is there. So in this extraction of zinc, three ores are there. First one is zinc blende, second one is calamine, that is zinc carbonate, and third one is zincite, that is Zn. So if we use all of these, then we can choose Froth flotation method. Froth flotation method. The concentration of ore is takes place by Froth flotation method, subjected to what? Roasting again. So here in roasting, what happens? If suddenness is there in presence of air, if it decomposes, means it gives ZnO plus SO2. Okay, if ZnS is there, if it is treated with O2, it gives ZnSO4. Okay, if ZnSO4 upon heating decomposes to ZnO plus SO2 plus O2. This is the way the roasting takes place. So this is what? Oxidation. Once the oxidation done means it must undergo reduction. How the reduction takes place? This ZnO is treated with carbon form Zn plus CO. Okay. Once we will get the crude metal, then refining takes place. That refining method is electrolytic refining. Electrolytic refining. Okay. Next, last one is, that is extraction of copper. Okay. So in that extraction of copper, we are using copper pyrite ore, CuFeS2. As it is a sulfide ore, it is subjected with what? Concentrated with Froth flotation process. Okay, if it is subject concentrated with fruit flotation process, then undergoes roasting. Sulfide ore means it undergoes roasting. So upon roasting, it what happens? It forms Cu2s plus Fe(S) plus SO2. So only crude Cu2s we will get. So upon that it will undergo smelting, means reduction and oxidation takes place. So this is for what? This Fe(S). For Fe(S), this melting takes place means it is removed as slag. Okay, and last, by using isomerization, this copper gets purified. Okay, sorry, extracted. How? This Cu2s, this is the electrochemical cell. So oxygen, this is Cu2O plus SO2. If this is Cu2O again reacts with Cu2s, it forms 6Cu plus SO2. This is crude metal. This crude metal is purified by, so the copper obtained here is in the form of a blister. That's why it is called as a blister copper. This blister copper can be purified by electrolytic refining method. Okay, this is all about the extraction of all the metals. In that another one is there, zinc and zirconium and titanium. Okay, so those are treated with iodine and as well as carbonyl, sorry, extraction of nickel and extraction of zirconium, that is Mons process and Van Acker process, that is depends on carbonyl compounds. They react with carbonyl compounds, they made it into volatile compounds and again they heated and the metal separated out, the volatile carbonyl group there easily evaporated. So this is all about the synopsis of that metallurgy. So in the next class we will discuss about the bits regarding this chapter. Okay, thank you.